Okay, so if we're approximating areas still, there's two other ways that we do it. One's with the what's called a midpoint sum. It's still a rectangle. Okay. Let me just give you a graphical example. Most of these problems are tabular. They use tables. Okay. So if I have a mid M, let's say M3, midpoint, 3 subintervals. Okay. With a left sum, you started left, right? Correct? Damon?
Yes.
Right-handed, you start on the right side. The midpoint sum, the height is in the middle. Okay. So basically, our height value here would be at 0.5. Okay. Your width is still 1, right?
Yeah.
But your height value comes from the middle. So your rectangles actually cross the function
So it's not really
graphically.
Okay.
So it's the middle point of the top of the rectangle. Okay.
All right, table, how would you calculate that?
Jeff, did you have a question?
So the M3 just means midpoint?
Midpoint,
Okay.
3 subintervals, yeah.
Oh, okay.
So this would, a question might say use M3 to estimate the integral from 0 to 3 of this function. Okay, I did not mention that yesterday in notation. I'm sorry. But it sounds like you guys figured it out. Okay. Right, so that's a kind of a graphical example of a midpoint sum, right?
How do you find, so I understand like you could just look at it on a graph, but in a table? How would you
Yeah, I'm going to show
calculate
you. All right, let's,
Yeah.
we cannot tell, actually.
Oh, so it could be.
We will not, I will not ask you if this is an over and underestimate because there's just, it's too close to call. There are ways to do it, I'm sure, and it has to deal with, it's very complex, so we don't worry about it, okay? Your over and underestimates are going to come from left and right, and then trapezoids, because they're all very easy to see. Mason.
So is the middle midpoint version more accurate? The fact that it has more
Yeah,
area?
it will be.
Okay.
Okay, let's look at a table here.
So application is usually for intervals, are it's usually going to be like the velocity and stuff.
A rate.
Okay.
In general, would be a rate. So it could be velocity, or it could be pounds per second.
Mm-hmm.
In the last few years, you've had a gravel processing plant that's processing 2 tons per hour, or decomposing grass that's decomposing at 3 pounds per minute. Tea is cooling off at 1 degree per minute.
Okay.
Things like that.
Lighter degree.
Okay. Okay, here's a table of values. We'll calculate M3. That's cute. We're on our game today, folks.
No, we're not.
Calculate M3.
It is game day now.
I hope so. I hope we're on our game today.
How cute. Who are we playing today?
Oh, wait.
Oh, yeah.
The losers.
Yeah.
Who cares? The kids-
Win the game, then talk the trash. Okay. So we want 3 subintervals, right? This is generally how these midpoint problems are asked. What are my intervals going to be? 0 to 1, 1 to, and, right? So look at this. See, they kind of set you up for a middle value, right?
Ah, okay.
Okay, so your middle value is your height. Right, so we're going to calculate M3.
So you're not going to give something where, like, so you have that same chart and it says calculate M6 on.
No, this question will not say calculate M6.
So they're
You do
always,
not have values between these.
they'll always present you with the value.
Yeah.
So
Yeah.
it has, okay.
Okay, so your width is still 1, right? Well, what's your height?
12.
12. And then,
1 to 25. Oh,
right? Okay, so yeah, you will be given values if you're asked for an exact answer. 51, I believe. Yep, so midpoint, use the middle value. Okay.
Oh, that's so much easier than this.
Yeah.
Separating this paradigm arm.
I've never seen a midpoint on the AP exam not be a table like this.
So I'm not gonna have nearly.
They could do this if they gave you the values here, but they just never have seen that. So we'll focus here.
Watch this beauty here.
You could have a function as well, but again, this is the best way to test this concept. So that's what they do. Okay. Questions there on midpoint calculation?
Wait, so did you get the numbers from the table from the graph?
No, these are separate. They're different. Let's look at trapezoid.
So, Mr. Arthur, so you know how yesterday you showed us that if the distance value was the same for all of them, then you can just add together the widths? Is that-
Yeah, so
is that
you
like-
could have done the same thing. 1 times 12 plus 25 plus 14. Same thing.
Okay, so that applies to any of them that are like-
If the intervals are the same.
Okay.
Okay, trapezoids. What is a trapezoid?
A square with a rectangle on top, or a triangle on top.
There you go. Okay.
Right triangle with a appendage.
Okay, there's one way to do it. Okay, the only thing that governs a trapezoid, 4 sides, and then the bases are parallel, right? That's a trapezoid. It can be presented in many ways.
So the squares technically is trapezoid?
No.
No, because then all of them are parallel.
Trapezoid is its own animal. What is the area formula for a trapezoid?
Half height times
Half
base
base
1
times height.
plus base 1, base 2.
That's a triangle.
Wow.
So you have your average the bases. That's B1 plus B2 divided by 2 times H. You are essentially creating a rectangle.
I need to write it here.
Okay, write that down. You're going to have it memorized.
I needed it, we're saying it over here. I needed it memorized for the BBA.
You'll have it now.
So I basically made a square.
That works too. Okay. generally, the trapezoids we'll be working with are tipped on end, and the parallel bases are vertical. This is how you're going to see your trapezoids.
Is it still the same formula?
Okay.
You can like only present it with like one triangle versus two?
Yeah, it's still the same formula. So you're still using this area formula, but you got to be aware that your bases are vertical and your height is horizontal. It's kind of counterintuitive. Okay.
Wait, I hope you didn't just say this, but I'm pretty sure you did. How do you determine which one's base 1 and base 2?
They have to be the parallel lines.
So it doesn't matter which
It
one.
doesn't
It
matter
doesn't
which
matter.
one's which?
No, you can change these.
Doesn't matter.
Addition is commutative. 2 plus 3 is 3 plus 2. Right? Okay.
That's a trapeze.
It is wood.
Okay. Okay, so this is just a function I made up. It doesn't have any algebraic. I'm sure you could put one to it, but we're not going to worry about that. Trapezoid. The trapezoidal sum.
Does R mean rhombus?
R is right Riemann. So we have L, left Riemann, R is right Riemann, M is midpoint, T is trapezoid. Right? We don't know circular sums, thankfully, because they just go round and round. Yeah, pretty much. Okay, so how many subintervals do we want? 3 subintervals. 6 units. How big are each interval?
2.
2. So you're going to draw your trapezoid.
The height is 2. So
That's your first
when
trapezoid.
you're drawing these trapezoids, you do like a right-sided, and then you just bring it down to the other. I don't understand how you do it.
Well, so your subinterval's this big.
Yeah.
Your bases just go up to the function,
Oh, okay.
right? And then you connect the dots. So, what is our height here? The width of this trap? 2. That's the height, right? H. That's this right here.
Yeah.
Okay, what is the base 1 and base 2?
4, 2,
4 and 3.
4, 3.
3 and 4, right? So the area under this curve, or T3, I guess we could write,
Is that?
1/2
Times
3 plus 4
times 2.
times 2. That's that trapezoid.
7.
Right. Okay. What's the next trapezoid?
It's 2.
2, 6,
6. 4.
Okay, so
5.
4 plus 6 times 2, right?
Jesus, dang it. I keep doing it to 3 at the end.
And the last one,
Can't you take the 2 out? Mister,
yes.
can you factor the 2 out?
I still think it's 40.
We're seeing an illustration of why we take our time on these. I'm hearing a lot of wrong answers. No?
They're close.
Can we factor the 2
I'll
out?
one off every single time.
You can.
You can.
And the 1/2.
Okay, I was just making sure because I don't know those rules sometimes.
So would that just pretty much be like 1?
That's it. 7, 10, 17, 15, 32. Okay. Is that more accurate than a left or right?
Yes.
Yeah, some. Yes, it is.
What does B mean?
Velocity.
Units squared.
Or is that a U? I mean, V is velocity.
Oh, you can have a V and you can have a U and then you can have a VOO.
That way, if you
Whatever
have
it
the
wants
boo,
to
you'll never be wrong.
That means you're wrong every time. Jason.
Why is the height 2 for all?
0 to 2? 2 to 4? Yeah, that's what I said. When you tip this up on in, the height becomes the x values in the formula. That's the one thing that gets people the most.
Oh,
So your h value comes from your width quote, and your bases are the vertical distance.
so it'll always be like that now?
Yeah, pretty much how we operate. You can, there are ways to simplify this. 1/2 and 2 occur in every one, correct? So we could write,
You can just add them because the 1.5 and the 2 cancels.
which is 1, right? What do you notice here? 3 occurs how many times? Once. But what about 4?
Twice.
It's in both of these, right? And 6 occurs twice, and then 9 once. So, you know, I've had students in the past that would go this route on trapezoidal sums and get very, very fast at it. I do not do that because I make mistakes. I just write it out. You write it out like this, it's still correct. You're guaranteeing that you're doing it right. You're going to
You
get
can stop there?
2 points on a free response for that right there.
Oh, well,
Okay,
then I'll stop.
so it'll say calculate the trapezoidal sum. They want this written out, some form of it. This would be okay. And an answer. Okay. This answer counts for the point, but this is a numeric statement. That would count for an answer too. Okay.
That's funny.
All right. Can I move to the next slide? I got one more. Just want to show you a table here.
That's been
Should I just make one up, or is that dangerous?
dangerous.
It's probably dangerous, yes.
I'll
Do
No,
not
all
listen to
of us are
Damon, he
proteges,
is
so
suicidal.
watch your face.
Okay, let's calculate T6.
Yeah, like
6
intervals. The sub
Yeah.
intervals. My hearing is really 6 sub intervals.
Yes.
Is that 12 or 1? Oh, those are, oh, it's the same table.
It's the same table as the first slide.
How'd you memorize that, or were you switching at any of those?
You didn't notice. I only did it like 3 times.
Oh, that's not a point, that's a 12.
12, yeah.
Like, geez, that was quite the leap. From 1.2 to 18.
It's been known to happen from time to time. We have some people in this school that need an IQ jump of that nature. Don't rag on yourselves. You guys are way above that. Even though you might be struggling in calculus, you're way above that.
At least you're struggling in calculus, you're not math.
All right.
Struggling in life.
Yeah, that's what I was talking to my cousins about. Like,
Okay, so your trapezoid formula, right? What are the bases in this problem?
why? Oh, no.
0 and 12.
0.5 is the
Oh, it
base.
is? Okay.
And then your height is 0.5.
3.5.
So can we
Okay.
do a quarter? Wait.
A quarter of 12.
Can we do quarter, factor out the quarter, and then just list them?
If they're all the same,
They're all the
yeah, yes, you can. Then we can move to the next one. Same, but we're at 12 and 18 now, right?
Right.
A quarter of 30.
7.5.
Okay, so you're thinking.
7.5.
Nice job, Jeff.
What?
Oh,
I'm actually smarter than one and he still feels like spotlight.
Smartness is not a momentary thing.
That is.
No, it's not. Intelligence is not a
21.
momentary thing. It's demonstrated in a moment, but it is not momentary. Do you need me to finish this statement?
Um,
Okay, so you would finish that up, right?
I'm still finishing it.
So with that other one, you do doubles of everything but the very first and the very last.
Yeah.
One
And again, if you want to, because these intervals are all the same, we could take the 1/2 and the 0.5, and you could just list this 0, 12, 12, 18, 18.
I like that way a lot.
It's faster. And then you're done. So you can make it easier if you want by factoring that interval out. Garrett.
If it said like T3
Right.
would be to skip the 12, it would be 0 and 18.
0 and 18.
Okay.
Yeah.
All of that plus.
So you can handle those?
So I have a question.
Yep.
If you go to do the bottom one where you factor out whatever your values are and stuff like that, could you, on the inside, to get numerical, like for not simplifying it, but numerical points, could you combine all the same ones? So instead of having 12 and 12, you have 24.
You can do that.
Okay.
Yeah. Yeah, as long as it's correct.
1 AD.
Yes. No, is that CD or AD?
It's AD.
C. We did A already.
Oh, this is the same worksheet.
Oh,
Same worksheet. So same sheet as yesterday. You have midpoint and trapezoid on there, and then 7.8 is where the book brings trapezoid sums in. We choose to put it all in one nice neat package. Okay.
Let's say 3 through 5.
Yes.
Oh, worksheet.
Wait,
Wait.
what is?
So for 3.5, we do B, C, and D.
This is 6.
Ah, crap.
So that's 3 through 5, and then 6 CD.
Oh, 6.
Never mind.
One is CD.
Yeah.
1 C and D, 2 C, 3 through 5, 6 C and D.
Okay, that's all I needed.
My muddy writing, apparently.
Yeah.
Your muddy thought pattern.
And then
It's a lot. It's not all weekend, it's till I get back.
Oh, yeah, huh?
When's that? Thursday?
The plan is Thursday, but if, I mean, you gotta think, if I'm out hunting, I get something Sunday, I'm probably gonna be here Tuesday and Wednesday.
So it's a gamble. I like this.
That's not how you should do that, Monte.
If I were you, this is good student advice, don't procrastinate, because you might forget what we talked about.
Right, I will definitely let you know.
Or you can depend on the video working, which is kind of a risk.
That's true gambling.
I love